Hello there, welcome to my channel on chemistry lessons. Predominantly it focuses on AQA A-level, but it also covers the BTEC Applied Science specification as well. The aim in this series of videos is to be as interactive as possible and to offer you opportunities to practice your questions as we go as well, and for me to go over and explain them. So please don't forget to subscribe so that you don't miss out on those blockbuster premieres, so you can be first on there to see them, and also use the comments features to let me know what you think and any videos that you'd like me to upload and add. So this video is a second year topic. It's the pH of acid. So we're going to be looking at some definitions to begin with, and then how we calculate pH of strong acids. So it's lesson 1 in a series of many. Lesson 2 we'll move on to look at bases and mixtures. So as always, we should start with the specification, and this is the spec points that will be covered today. Okay, so looking at the definitions for the top section, and then just below that, the calculations. So straight off with definitions then. Literally, if you are asked to define an acid, you can just say proton donor. And to define a base, it's proton acceptor. So just to kind of clear up what that actually means, a proton in terms of chemistry is just a H plus ion. If you don't believe me, remind yourself what hydrogen is. Hydrogen is 1 electron and 1 proton. That's all it is. It's got a proton in the nucleus, no neutrons, and it's got 1 electron around the outside. If it loses that electron, it literally becomes a proton. So hence the term proton donor. And we use H plus to show the proton. And base being a proton acceptor. And you may be familiar with some of these terms from GCSE. The idea that a strong acid fully dissociates in water. Perhaps weak acids partially dissociate. So what I mean by that is, for any acid, has to contain a H, because we know that it's a H plus, it's a proton donor. So a strong acid fully dissociates, and we show that with an arrow. Fully dissociates into its ions. Whereas a weak acid partially dissociates, and we show that with an equilibrium sign to show that it's only a partial, it's not a full dissociation. And again, a strong base by definition then completely ionizes. The term, I've purposely used different terms here, dissociate, ionize, same thing here. It either dissociates to its ions or it ionizes into its ions. Fully, completely, just same meaning, different words. And again, a weak base slightly dissociates. Slightly, partially, we can argue the toss there, same thing. And again, dissociate, ionize, same thing. If you look back at the spec, you'll see that it mentions an acid-base equilibrium. Okay, so let's have a look at this acid-base equilibrium above here. So we need to be able to recognize acids and bases in this equilibrium. So if we look at the forwards reaction first, what is releasing a proton? What's donating the proton? And in this case, HA is donating a proton to become A minus. So in this case, HA is acting as a proton, and if we look at B, B is accepting the proton, so B is a base. So in the forwards reaction, B is the base and HA is the acid. But if we were to look at this reverse reaction then, if we look at the reverse reaction, in the reverse reaction, A minus is accepting a proton. So we call A minus the conjugate base, because in the reverse reaction, it's accepting a proton. So it's the conjugate base, A minus being the conjugate base. And BH plus is donating a proton in the backwards reaction. Therefore, BH plus is classed as the conjugate acid. Okay, and we can pair them up. We could pair B and BH plus as the base conjugate acid, and HA as the acid conjugate base. Because that makes sense. If it's acted as an acid in the forwards reaction, in the backwards reaction, it's acting as a base. Okay. So going back to our strong acids then, we should be familiar with 3 strong acids: hydrochloric acid, H2SO4 sulfuric acid, HNO3 nitric acid. So those are our 3 strong acids that we should be aware of. If they were to give you a different strong acid in the exam, they would need to tell you what it was. but these three, you should know that these three are strong acids. They fully ionize in water. For example, HCl fully dissociates to H plus and Cl minus. H2SO4 will fully dissociate. H2SO4 has two H pluses, so one sulfuric acid can actually donate two H pluses. And we'll talk about that in a minute. HNO3 nitric acid fully dissociates to H plus and NO3 minus. So HCl and HNO3 are known as monoprotic because 1 mole of acid releases 1 mole of H plus. Sulfuric acid is classed as a diprotic acid because 1 mole of acid releases 2 moles of H plus. So it's a 1:2 ratio. You need to be aware of that. You need to be careful when we do calculations shortly about that molar ratio. So 1 mole of diprotic acid releases 2 moles of H plus. Right, opportunity here for you to have a go at practicing these definitions. So pause the video, have a go at these 2 questions, and when you're ready, unpause the video and we'll go through it. Okay then, so we've got nitric acid is a strong acid, ethanoic acid is a weak acid. They're telling you a strong and a weak acid. Write an equation to show how ethanoic acid behaves as a weak acid in its reaction with water. Okay, so we've got nitric acid with water. Now it's weak, so I'm going to show it as a reversible because it's a weak acid. Now I'm going to show the acid donating a proton, so it's going to release its proton to become COO minus, and the water will accept that proton and become H3O plus. So what we're actually showing is water acting as a base and ethanoic acid acting as an acid. Okay, when pure ethanoic acid reacts with nitric acid, ethanoic acid acts as a base. Slightly confusing, but okay, let's show that. So we're going to show the nitric acid donating a proton, and we're going to show our ethanoic acid acting as a base and accepting a proton. So the key thing to look out for here is just the movement of the H plus, okay? They try to confuse you in questions from time to time, and you're just looking at the movement of the H plus. If something is losing a H plus, in other words, it's donating it, it's an acid, or if it's accepting it, it's a base. Or if you are told it's acting as an acid, you have to make it lose a H plus. And if you're told it's acting as a base, you need to show it gaining a H plus. Right, question 2 then. So using that same logic, we're asked here for which one shows an acid-base reaction. Now, does the OH minus gain or lose a H plus? Doesn't look like it does, if I'm honest. In part 2, NH3 becomes NH4 plus. That's showing it accepting a proton. That's showing it acting as a base. And HCl is losing, yes. So I think that does show the movement of a proton. KF, PF. No, that doesn't look like the movement of a proton. In the last one, water is accepting a proton and water is losing a proton. So we've got, yes, that's an acid base. So I think 2 and 4 are correct. So the correct answer here is C. Right, okay, so what we need to do now is look at actually calculating pH. And this is where it starts to get real from GCSE. Okay, so it's very kind of real now. In fact, it's really logtastic. It's logarithms, which is when logs dance really well. They've got logarithm. Obviously, it's not. It's just a maths thing, but we'll have a look at that. Got to be trying a bit of joke there. Never mind. We'll move on. Right. So just remind ourselves of what happens when acids dissociate in water. So it's solution. They dissolve in solution. So we've got some groundwork here already from first year topics with concentration, moles and concentration calculations. So we've already used in first year moles is concentration times volume, therefore concentration is moles over volume. We're going to be using this an awful lot. Okay, now sometimes you'll see it written as a reaction with the water where the water accepts a proton, becomes H3O+. H3O+ and H+ are kind of interchangeable. Okay, so when you see H3O+, you see an H+. Right, let's remind ourselves of what the pH scale was, because we were introduced to this in quite probably primary school in some cases, if not year 7 definitely. So it's something that we come across. Now, the pH scale is something that we use to describe the acidity of something or the alkalinity, so whether it's an alkaline or an acid or neutral. And we're all pretty good at that already. We have that knowledge with us. The big problem it brings, though, to A level is that people think it's a measure of the strength of an acid. It's absolutely not. It's just a measure of the acidity, and the acidity and the strength are absolutely different. The strength of an acid is totally about the dissociation. So a strong acid, it's a definition, it fully dissociates. It's nothing to do with pH. If you are asked to define a strong acid and you say pH 1, pH 2, no, you're wrong. A strong acid fully dissociates into its ions. The pH scale is a measure of the hydrogen concentration. That's what it is. The pH scale is a measure of the hydrogen concentration, but it's on a logarithmic scale, okay, which is basically a movement of 1 is like a movement of a factor of 10, and we'll look at that in a minute on the next slide. When we calculate pH, we are going to calculate it to 2 decimal places. That is our default. So in the exam, when you're asked to calculate pH, use 2 decimal places. And the pH is equal to minus log of H+. Now this requires you using a calculator. So in a minute, I'm going to get you to do some practicing on using your calculator just to make sure you can use the log button on your calculator, because believe it or not, some people have probably never used it or don't use it, don't know how to use it, so we're going to have to do some practice. Changing then, so pH is minus log of H+, or to rearrange it to get H+ equals, because you're going to be asked to do 2 things in exams. You'll either be asked to calculate the H+ concentration from a pH, in which case it's 10 to the minus pH, or you're going to be asked to calculate the pH from the H+ concentration. So you need to be aware of both of these, or being able to change between the 2 of them. Okay, so let's look at the pH scale then. So here we have a pH scale, and from 0 up to 14. And it just surprised people at the pH scale. You can actually have a negative pH, and we'll see some of those examples later on in the video. So 10 to the power of 0, so if pH is 0, and the H+ concentration is 10 to the minus pH. So we can see here, so 10 to the 0 would be pH of 0, that's 1. So if the H+ concentration is 1 mole per decimeter cubed, that's pH 0. And as you move down the scale, 0.1, 0.01, 0.001, so a movement of 1 place on the pH scale is a factor of 10 in the concentration of H+ ions, hence the term logarithmic scale. So from 0 to 1, it's a dilution of 10, so it's 10 times the concentration. And again, from 1 to 2, it's another 10, and so on and so on. So it's a logarithmic scale. So you can see at pH 14, the H+ concentration is very, 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 very small, 10 to the minus 14. And at pH 7, the H+ concentration is times 10 to the minus 7. Okay, so the pH scale is directly linked to the H+ concentration. It's minus log of the H+ concentration. You are expected to be able to use these 2 formulas. Okay, so what you need to do now, you can do just a little bit of practice using your calculator, because from my experience, people do struggle if you've not, if you're not comfortable with your maths, you don't study A-level maths, you may not be used to using these buttons on your calculator. So let's have a bit of a practice, okay? So what you're going to do is there's 5 examples there. I've got a concentration of acid for the first 4, and you can see how they relate to pH, so see if you can convert it. It's just times 10 to the minus. I will just point out though, on the fourth one, sulfuric acid, because it's diprotic, you can see that the concentration of the acid and the concentration of the H plus ions are not the same. I've had to double it because it's diprotic, because 1 mole of acid releases 2 moles of H plus. It's a 1:2 ratio when you move to the H plus. So the first thing I'm doing here is the concentration of the acid. I'm determining the concentration of the H plus, and if it's monoprotic, it's the same thing. Okay, so HCl is monoprotic, HNO3 is monoprotic, so the concentration of the acid is the same as the concentration of the H plus. It's just when it's diprotic, the concentration of the acid is only half the concentration of the H plus. So be careful there. And then the last example here is going from a pH to a H plus concentration. So you just pause the video and spend some time looking through those 5 using your calculator. Can you convert those concentrations of acids into pH? And can you go back over? Can you convert those pHs back to the concentration of the acids using these 2 equations over here? So when you're comfortable with that, when you've played with your calculator and you've had a move through those conversions from acid concentration to pH, when you've done that, unpause the video and move on, and we'll do some exam questions. Okay, so this is similar then, but this time I've not put the answers on the board. I'm going to put them on shortly. So what you want to do is, we've got 1, 2, 3, 4, 5, 6 acids. The first 3 you know their concentrations. So what I want you to do is to fill out the table. So you're going to fill out the column for the H plus. You're then going to convert the H plus concentration into a pH. And then for the last 3, you need to work back over. You need to go from the pH to the H plus concentration. And once you've done the H plus concentration, then determine the concentration of the acid. Remember to be careful with diprotic or monoprotic. So pause the video and do that. And when you're done, unpause the video and the answers will appear. Okay then, so hopefully monoprotic, it's just 2. And then minus log of 2 becomes minus 0.3. So there's your first experience possibly of a negative pH. But notice how I'm using 2 decimal places. Next one, again, monoprotic, 0.6. And if you do minus log, it's 0.22. Next, got to be careful here, it's diprotic. So we had to double the concentration of the acid to get the concentration of the H plus. And then pH comes out at minus 0.20. Working back over then for the next ones, the H plus concentration, and that is the same as the concentration of the acid. Again, 10 to the minus 1.66 comes out at 0.0219, so there's your concentration of nitric acid, and again it will be the same because it's monoprotic. And finally, the H2SO4 concentration, H plus concentration 10.96, which means the concentration of sulfuric acid was half that value because it's a diprotic. Okay, so let's practice a couple of exam questions then. So you know the drill by now. Have a go at the questions. So pause the video, have a go at the questions, and when you're ready to go through them, unpause the video and you'll hear the answers. Okay, so question 1, we're asked to determine the pH. Now pH is minus log, and it's log to the base 10, of the H plus concentration. So the only way we can find the pH is to find the H plus concentration. We know the concentration of the acid is 0.020 moles per decimeter cubed. We know it's a diprotic acid, and we know it completely dissociates. That means that the H plus concentration is 0.040 moles per decimeter cubed. Because it's a diprotic acid, 1 mole of acid will release 2 moles of H plus. So I've had to double this value here. It's a strong acid, it's fully dissociated. And now minus log to the base 10 of 0.040 comes out at 1.397 something, which to 2 decimal places is 1.4. Correct answer here is B. Now question 2 is quite tricky, but let's just focus on what we need to do. We need to find the pH. To find the pH, we must find the H plus concentration. So we need to find the H plus concentration. Now what they're doing in this question is they're diluting it, okay? Now concentration is moles divided by volume. So what we're going to do is find the moles of H plus, and the H plus is coming from the acid. So moles is concentration times volume. So I'm going to find my moles of H plus. Now I know my volume and concentration of HCl. It's monoprotic. I know that HCl is monoprotic. So if I can find my moles of HCl, I'll know my moles of acid. So my moles of HCl is concentration times volume, which is 0.0850. My volume is 25 over 1,000 because it must be in decimeters. And if I put that into my calculator, I will get 25 over 1,000 times by 0.085. My moles of HCl here is 2.125 times 10 to the minus 3. Now I know that that's also the moles of H plus because this is a monoprotic strong acid. So my moles of H plus are 2.125 times 10 to the minus 3. So I know my moles of H plus. What's the volume? Well, the volume is 25 plus 100 because they added 100 centimeters cubed. So my volume is 125 centimeters cubed, which is in fact 0.125 decimeters cubed. So now to find the concentration of H plus, it's 2.125 times 10 to the minus 3 divided by 0.125. That's going to give you my H plus concentration, which is 0.017. And if I do minus log of that, I will get minus log base 10 of 0.017. That equals 1.77 to 2 decimal places. Next question then. So again, pause the video, and when you're ready to go through it, unpause and we'll hear the answers. Okay, writing an expression for pH. pH is equal to minus log of H plus concentration. Minus log of base 10 H plus concentration. And calculating the pH of 0.154 moles per decimeter cubed of HCl. Now we know it's a strong acid and we know it's monoprotic, so we know that the H plus concentration then is just the same as the acid. So if we punch that into the calculator, minus log base 10 of 0.154 is equal to 0.81. So my pH is equal to 0.81 at 2 decimal places. Part 3, similar to what you've just done in question 2, so hopefully you found this one a little bit easier this time. So it's calculating the pH, so we know the moles of acid, so we know that the moles, well no, we don't know the moles of acid, sorry, we need to find the moles of acid. Moles is concentration times volume, which is going to be 0.154 times by the volume, which is 10, but it's 10 over 1,000 because it must be in decimeters cubed. So moles of H plus here, just work that out on my calculator, 0.154 times by 10 over 1,000 is equal to 1.54 times 10 to the minus 3. Now we need to find the H plus concentration, which is going to be moles over volume. We've just worked out our moles. The volume is 1,000 centimeters cubed because it's 990 plus 10, which is 1,000 centimeters cubed, which is 1,000 over 1,000. It's 1 decimeter. So H plus concentration is just divided by 1. So we now know, work that out. So we can just do minus log base 10. So minus log base 10 of 1.54 times 10 to the minus 3. That pH, so pH comes out at minus log base 10 of 1.54 times 10 to the minus 3 to 2 decimal places is 2.77. 0.81. How cool is that, being able to predict pHs without using any apparatus whatsoever? Hope you enjoyed that as much as I did. I'm going to have to go for a lie down now. Please make sure you hit that subscribe button if you haven't already. Don't miss out on the future videos. So the next lesson that we're going to be looking at here is going to be looking at the pH of strong bases. Now, you don't want to miss that one, do you? So look out for those. It's a very enjoyable topic, this one, albeit quite confusing if you can't do it. It is very mathsy. So hit that subscribe button, use the comments, let me know what you think and what you need. Good luck.